So there are a few steps. One is to create a library file, and then to copy SL plus to your own directory and then modify it. There are two places you have to modify. One is the name. That one is not the necessary one. The important one is the open function. You have to link it with your own MDL file, so it will be searched and added to the group. So next time, if you open this group, it will be displayed automatically. So you can create files and then edit it with your own group. So this is a very brief introduction to Simulink, and let's see how can we solve ordinary differential equations with the use of Simulink. And I have already explained that if you are using ODE for 5, then we can easily solve an ordinary differential equation. However, if the ordinary differential equation is a part of a system, for instance, if it is a class model, which can be expressed by a differential equation. Before it, there is a PID controller. I always use PID controllers as examples. If there is a PID controller in front of it, then it is not possible to use ODE for 5 because the input signal is not known. So we have to use Simulink to create block diagrams. So in this case, we have to use Simulink rather than Matlab equation solvers such as ODE for 5 for these kind of problems. And here I only want to demonstrate through examples how can we model ordinary differential equations, how to solve it, and then we should move on to system simulation. So let's consider an example first. If there is a Lorentz equation which are given by differential equations like this, and from our knowledge, we can easily write a .m file to describe the differential equation and then use ODE for 5 to solve it. It is quite easy. If we want to solve this system, solve this equation by the use of Simulink, we have to draw Simulink block diagrams. And for this equation, what we need to do first is to define signals, because we have to use x1 signals, x2 signals, and x3 signals. We have to define the signals. Once we have defined the signals, then we can easily create block diagrams for it. How can we define a signal? We can indicate that one line in Simulink window describes signal x1, any line. And then we can use an integrator here. If we are using an integrator, then the left-hand side of the integrator should be x1 dot. And also we can easily create x2 signal and create x2 dot easily and x3 dot easily like this. So we can create 6 signals which are useful in this block diagram. Then, how can we model this part? Minus beta times x1. We can use again, the value of the gain is minus beta. And this one should be minus beta x1. And then, how can we describe these two signals, the multiplication? We can use a multiplication block to multiply the two signals together, and then we can add these two signals together. And it can be seen that this signal should be the same as x1 dot. So what we need to do now is to connect these two together. So we can describe the first equation in this way. It is slightly different from the program. We have to get familiar with this kind of representation for later uses. And this one we need gains here. X2 and X3 we need a gain row. And then we need to add them together. This one should be minus, this one should be positive. And then we can connect this signal with this one, because they are equivalent. And also we can model the third equation. In this way, we can easily draw from diagrams for the differential equation. Let me see that this way is quite complicated compared with the method we described earlier for this particular example. But for complicated systems, for instance, if this equation is part of the Matlab model, then we have to model it in this way. There's no alternatives. So we can create a simulink from diagram for the differential equation. And the differential equation we created is D7 or 1D. This is the one I've already created with the use of, this one is slightly different from the one I described there. But they should work the same. So I will explain this kind of description. It is an alternative way to model a system like this, or model a differential equation like this. We can define the signal x, which is a vector. And the vector is created, it consists of three signals, x1, x2, and x3. It's created with three signals. Again, we have to use integrators. And then we can have x3 dots, x2 dots, and x1 dots. Let's go back to the mathematical description of it. For the first equation, we have to create a nonlinear function from the f vector. This is, we have to use a block in simulink groups like this. We have to connect them together like this. So what we should add to this block? This block should be minus beta x1 plus x2 and x3. But for this kind of block, we cannot use x1 or x2 or x3. What we should use is the U signal. The U in this case equals to x because we use the line to connect them together. So what we have to use is the U signal. So in this case, there should be beta as a constant times U1 plus U2 multiplied by U3. We have to add this string into this box to describe the function, and in this case we can establish the first equation, and then we can describe the second equation in a similar way, and then the third. So finally we should have a block diagram description like this. And this kind of description is much easier than the one I described there, because we